Hello, my name is Gabe. For this problem, we're asked to solve this system of equations. Let's begin by noting that there's two equations and three variables, so our system cannot have a unique solution. This means that our system will either have no solution or infinitely many solutions. So to determine how many solutions our system has, let's begin by putting the system in echelon form. Now to write the system in echelon form, we can multiply the first row by 2 and add it to the second row. So multiplying the first row by 2, we have 4x minus 6y plus 2z is equal to negative 4. And our second row will leave the same as negative 4x plus 9y, and this is equal to 7. Now adding these together, we'll have 0x plus 3y plus 2z equals 3. So we can substitute this equation in for our second row, and we'll obtain the system 2x minus 3y plus z equals negative 2, and 3y plus 2z equals 3. So now our system's in echelon form, and our system is not inconsistent, so we will have infinitely many solutions. So here, we can solve for y in terms of z. So let's consider our second equation, 3y plus 2z equals 3. Our goal here is to solve for y, so we can subtract 2z from both sides of the equation, and we obtain 3y is equal to 3 minus 2z. Finally, we can divide both sides by 3, and we have y is equal to 3 divided by 1, which is 1, minus 2z divided by 3, which we can write as 2/3 z. So now we have y written in terms of z. Now we can substitute this into the first equation to solve for x in terms of z. So we'll have 2 times x minus 3 times y, which we said was 1 minus 2/3 z, plus z equals negative 2. So we'll begin by distributing the negative 3. So we'll have 2x minus 3 plus 2z plus z equals negative 2. So here we can add 3 to both sides of the equation and subtract 3z from both sides of the equation to obtain 2x is equal to 1 minus 3z. And finally, we can solve for x by dividing both sides of the equation by 2. So we have x is equal to 1/2 minus 3/2 z. So now, since z is arbitrary, we can just go ahead and we can let z equal a, where a is any real number. So z equals a will be part of our solution. Y will be equal to 1 minus 2/3 a. And x will be equal to 1/2 minus 3/2 a. And this is our solution to the system of equations. Now to check that this solution satisfies our equations, we'll want to plug these values into both of our equations. So starting off with the first equation, 2x minus 3y plus z equals negative 2. We'll substitute 1/2 minus 3/2 a in for x. We'll substitute 1 minus 3 halves a in for y, and we'll substitute a in for z. So here, we want to know is 2 times 1 half minus 3 halves a minus 3 times 1 minus 2/3 a plus a equal to negative 2. Well, using the distributive property, here we'll have 1 minus 3a minus 3 plus 2a plus a, and we want to know, is this equal to negative 2? Well, here we'll have 1 minus 3 is negative 2, and we have minus 3a plus 2a plus a, so these will cancel, and we're left with negative 2 equals negative 2. So this is a solution to the first equation. Next, we'll substitute these into our second equation. Negative 4x plus 9y equals 7. So we'll substitute 1 half minus 3 halves a in for x, and we'll have negative 4 times 1 half minus 3 halves a plus 9 times, we'll substitute 1 minus 2/3 a in for y. And we want to know, is this equal to 7? Well, using our distributive property, we'll have negative 4 times 1 half is negative 2. Negative 4 times negative 3 halves a will be a plus 6a plus 9 times 1, which is 9, and then minus 6a. And we still would like to know, is this equal to 7? Well, here we have a 6a minus a 6a. Those will cancel. And we have a negative 2 plus 9, which is equal to 7. So we end up at 7 equals 7, which is a true statement. So the solution to the system is z equals any real number a, y is equal to 1 minus 2/3 a, and x is equal to 1 half minus 3 halves a. Thank you.